Hi, welcome to Think Human. I'm Chris, and in this video, I want to talk about what does a scientific theory actually mean. So, commonly, it can be quite easily misunderstood. I'm sure you have done it maybe yourself or seen people do it. When someone says, like, the theory of general relativity, then some people might have reactions like, oh, it's just a theory. It's not as serious or as valid or as objectively true as some other kind of law of nature. So these people are confusing what does a scientific theory mean versus a hypothesis. People think that a theory mean what a hypothesis actually means. Hypothesis is that I hypothesize that something is a certain way about the world, and that is my hypothesis. It's not yet proven. There is no experiments done, there is no tests done, nothing like that. It's just some kind of a starting assumption about the nature of reality. A theory is something that is already working, and to understand better why it's called a theory and no longer a law of nature, let's think about there's Newtonian mechanics. So Isaac Newton, really brilliant guy, in his early 20s invented a whole new kind of mathematics, just a genius guy, brilliant. He found equations, he made up equations that can explain and predict the world, and they were called laws of nature, the Newtonian mechanics and all the rest of it. So these are laws of nature. So as we got smarter, we learned more, we did some more studies, and a lot more brilliant people are born and do their work and all of that. And then we get to Albert Einstein in this example. So Albert Einstein does his work on the theory of general relativity. Now, what happens is that the theory of general relativity includes is much more expansive than Newtonian mechanics. So the theory of general relativity has a much deeper understanding of the nature of reality, of space and time itself, than Newton's mechanics ever did. But regardless, Newtonian mechanics are still in the Einstein's theory of general relativity. So the Newtonian mechanics are now still in this bigger framework of this general theory of relativity. So the reason why it's called a theory is because of a kind of change of mindset. We might as well call the theory of relativity a law of nature, but why we don't is that it's very likely that the theory of general relativity is also an approximation of actual laws of nature. So it's a kind of approximation because it can have other aspects to it. It can be expanded upon. For example, in the theory of general relativity, where it does not give any valid answers is if you go to the quantum scale, to the really small scale, and then you look at gravity. So the theory of general relativity breaks down and can't answer any questions about the nature of gravity if you go to quantum scales, really small scales. So the idea being that no one will ever disprove Newtonian mechanics. They are correct and right and always will be. The theory of general relativity, what it explains, will never be disproven. It is correct. It is a scientific fact. It works. Some aspects of it might change in little kind of ways, but the nature of it, the foundational basis of it will always remain true. So they will never be discredited. The only reason why it's called a theory is that there can be even a larger theory discovered later that can encompass the same way that Einstein's theory of general relativity had Newtonian mechanics in it. This new theory can have general relativity in it and has a much more, again, kind of leap forward, a much more expansive understanding of the world that we're living in. So this is the true reason why it's called a theory. It might as well be called a law of nature, but it's called a theory because it leaves room for some kind of expanded theory about the world. And these theories will never be disproven, like I said. Like, they are correct, they are accurate descriptions of reality, but they're not the whole picture. It's like we're mapping out the world we live in, and we're drawing a map, and we go over it many times, we do experiments, we verify that our map is correct. No one will ever disprove our part of the map, but it's not the whole picture. You can't call it the entire map. The theory is not the entire map. So This leaves kind of space for future understanding to be expanded upon, and most theories currently are these kind of theories that leave space for something more, which maybe one day could become what we could call a law of nature. But this is just a simple explanation of why it's called a theory instead of law of nature. It might as well be law of nature, but it's a bit more different than that. So I hope it was interesting in some way. If you have any ideas, please share them in the comments, and of course, thank you so much for watching, and take care.